Hi, my name is Matthew, and for the Object-Oriented SW and UML section of the videos, let's first start off with designing before coding, which is basically avoid coding incorrect solutions. That's what it's for, and it's to increase the abilities of others to code in parallel. So basically, the example that Dr. Grissom gave was that he could code part A while someone codes part B, and that even though B might implement methods from part A, as soon as part A is done, B will work. So basically, just coding together, making it easier on people. So moving into the object-oriented part, so the analysis for this was the goal is to turn high-level description into a software design. The steps for this is to look for keywords and map to the object-oriented constructs. Attributes don't need to choose a data type at this point yet. And then you got to be careful of what classes you use as methods. So basically, just be careful you don't use too many. Um, then moved into the UML, which is Unified Modeling Language. Um, that's what it stands for. The structural diagrams, class diagrams. So basically, it describes how classes in relationship among classes work and how classes will interact. This is basically, I parallel this to databases. Basically, in databases, it's the same thing. Classes and how they work together. So one to many to many. Uh, that's how I was able to understand it. Just thinking back to database. So class relationships. There's association, which is A uses B. Inheritance, where it's A is AB. Realization, which is A implements the B interface. Dependency, which A depends on B. Aggregation, which is A is not the exclusive container of B, and composition is if A is deleted, then so is B. And the multiplicity of this is association number, so it's could be 0 to 1, 1 to 1, 1 to many. So basically, this was shown as a car with wheels. So wheels are definitely going to have one car. Wheels don't get tossed around from car to car daily, so only one car uses those wheels. But a car may need 4 to 5 wheels depending on a spare tire. So basically, that was a one to many relationship, and then it had one dot 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 five because you could have up to 5 tires. And then doing some research of UML, I actually went to the UML website. Um, Basically, on here, I found that UML is very useful in letting us work at a higher level of abstraction, as said right here. Basically, so we can focus on the big picture rather than the small things, which I think is really good. And then you could use some tools to analyze existing source code. So basically, making sure it works and to reverse engineer it into a UML diagrams. So that's just to make it easier on people. And UMLs is basically to help understand your code better. That's basically what I got, and understand what you're doing as a unit. Um, and basically also some tools on the market, execute, executable UML models. It just helps execute things, and it helps the team really understand what they're doing. So I think it's really cool. And the next part is once you shared your findings, briefly provide your thoughts on UML. As I said, I think it's really useful. It helps people understand what's going on, what the dependencies are for classes, because definitely if you just go into code blindly, sometimes you can forget about a class and forget about what it has, especially like abstract classes and stuff. So I definitely think the UML is important, and it also helps you not have extra classes because sometimes we may have a class that's just like, why do we have this? This is not needed. So I definitely think UML is very important in keeping organized and understanding what the group is going to do and understanding how it's going to work on the market with the multiplicity. All right, thank you.